Hello, everyone. Welcome to our webinar discussion today on AI agents, specifically the leveraging of AI agents across an entire AML process with a focus on assisting AML investigations from start to finish. What we'll be covering here today is going to be an initial setting of the framework and architecture, both in terms of what the level setting will be in terms of what agents will be and how they will be assisting us, and then what is the specific framework and architecture that Dataiku has suggested here. And then very quickly, we will be moving into a live demonstration led by David, who is our data science business solutions senior manager. That will be the heart of this meeting, in which you'll get a chance to see the framework and architecture fully functioning inside of Dataiku. You're going to basically get to see two fundamental elements as a result. One, exactly what the proposed project will achieve inside of Dataiku and how it would very materially assist an AML investigation. And then after seeing that kind of front end component, you'll see the back end and how Dataiku makes it very easy and extremely safe and governed and secure to build out these kind of systems, and also how flexible they are. What you're going to see here was built entirely in Dataiku, but that therefore means that it could be entirely customized in Dataiku as well. Agents as a whole will indeed be game changers within the FSI space. And we can talk about a couple of levels along which that would be relevant. So when you think about an agent, you are moving well beyond the general idea of either basic automation or the idea of some kind of chatbot interface with a large language model. Chatbots can be a part of an entire agent framework as a way for the user to interact, but they are not the heart of it. In fact, the most fundamental part of an agent architecture is the use of reasoning, in which the agent is making decisions in order to assist the human that it's collaborating with. If we think about this overall, we move away from very rigid rule-based systems. Those may still be part of an overall project framework, but they are not at the heart of the differentiating factor that the LLM agent brings in. Instead, you can move into a reasoning mode, in which decisions can be made by the agent to move the activity forward. The other element that is very much impactful and can bring a huge amount of benefit is that the agent is capable of performing multidimensional analysis. This could be analyses across many different fragmented data sets that are all structured. It can also be work across unstructured data sets that might be either inaccessible or extremely time-consuming to engage with in their current form. And also, as you will see later, it allows for interactions with data sets that go beyond a simple table or a text document and into areas of significant value like graph analytics. And in all of this case, this is about a collaborative experience with the human agent. The human agent remains in charge of the entire investigation and process, and they are being assisted at each stage by various agents working together with them. In terms of the benefit that agents can bring, there are their capabilities we just discussed, but the benefits are rather straightforward and can be immediately evaluated simply by watching them in action, as you'll see shortly. You will obviously have significant efficiency. The agent is capable of tirelessly poring through a very large amount of information, be that a graph, be that databases, be that text documents, in order to extract potentially relevant information and then summarize it. As a result, you're able to move across a vastly larger sweep of data and many different types of data than would have been plausible before. That approach can be extremely consistent in its nature. So you are able to ensure that once you are comfortable with the agent arrangement, the actual manner in which it is performing those behaviors is extremely robust and well understood. All of this, of course, can improve general satisfaction for your agents, but also significantly reduce fatigue in those human operators. So you will be reducing things like alert fatigue and also allowing them to focus more on the most meaningful and relevant information, using the best of their abilities. Within financial services broadly, there are, of course, many different potential use cases. Here's a very small selection that we could speak about perhaps later on. Any questions, comments, or thoughts as we move through, feel free to leave them in the chat or in the dedicated question and answer section. All of that we'll be tackling after the demonstration near the end of the conversation. In this particular discussion, though, we're going to move into a conversation about this AML investigator that will assist a human operator in performing their investigations. Now, at the high level, this investigator performs exactly the kind of elements that you would want. It is enriching a lot of the analysis that would have already been performed. It is taking some of the most mundane tasks or tasks which are very difficult to scale and allowing them to be formed at very large scale and extremely efficiently and quickly. It's also, though, using its decision-making capabilities to help rank the information. Rather than providing simply one massive amount of analysis covering every possible opportunity, it instead sensibly looks through those opportunities, evaluates them, and then decides which ones should be prioritized and thus brought to the attention of the investigator. So that surfacing, that decision-making in terms of what is most important, which avenues to pursue, is extremely beneficial, far more so than simply cranking through a very, very wide array of possible pieces of information. It will also generate supporting material that can be useful. So if, for example, it is plausible that a SAR escalation might be necessary, a packet could be produced providing a lot of the basic information that would be necessary for that SAR to be completed that the operator, the human operator, could then work with. So in all of these cases, the human operator is being assisted. But just as importantly, the human operator remains in charge. They are essentially managing that process. They therefore have at every opportunity the ability to dive deeper or to pursue areas that the agent did not pursue. They can do this either via the chat interface or by going into the dedicated components that are essentially the human equivalents of what the agent had engaged with, like graph or data analysis. If we think then about the kinds of areas that this would be addressing, specifically not to the entire industry, but to this very particular challenge, you, of course, will be reducing the load on investigators, allowing information that might be in very disparate systems and different forms to be very rapidly brought together and accessed. You will be able to apply a very consistent process and, of course, therefore reply more effectively to pressure that you receive. All of this together allows the human operator to perform at an even higher level than they already were, with greater confidence and efficiency, as well as with greater focus. If we then look at what the actual architecture of all of this is, I think this is one of the most important components. As you think about an agent in operation, what you are essentially needing to understand are the ideas of interfaces, so the way in which the agent is engaging with the human operator. You need to think about each individual agent as perhaps performing in an ensemble in which a overseeing agent is leveraging the work of other sub-agents, and those agents leveraging tools. The tools are therefore able to perform specific things that need to be achieved. This breakdown, this kind of simplifying framework, is exactly how Dataiku allows agents to be built. So as you see after the demo of the actual human experience, you'll be able to see all of the material under the hood in which these components like tools, agents, and then an ensemble architecting agent on top, all behaving together in a very well-governed, well-managed way. As you can see here, these are also modular. So you can allow an agent which has a general data search capability and is looking across many different systems that could themselves be disconnected from one another, but it's bringing them together. You have another agent that's dedicated solely to graph analysis and is therefore extremely efficient at one particular task. And then yet another agent that is looking for politically exposed persons and otherwise investigating the kind of human component of the potential risk profile. All of this then being brought together into a summary report that is very specifically graded and decided upon by the overarching AML assistant agent. The agent will decide what components should make it into that report and in what order they should appear. And all of those components will explain themselves and then can be dived into deeper, as I said, either in a chat interface with the agent or by having the human go directly into those systems, as you'll see. All of this allows the investigator to participate in the process. They are not being given a decision. They are not being told what to do, nor are they just given some massive dump of thousands and thousands of data points and possibly vaguely useful information. They're giving a refined packet of usable material that they can then interact with and move forward from. All of this also is supported by a separate agent, which basically prepares a potential star packet, which could be leveraged then by the investigator. Again, this is simply allowing them to move quickly and allowing them to make the most fundamental decisions about how to then action the alert. We'll move now into a demonstration led by David, in which you will be able to see all of these components operating. You will see both what it would be like to be a human operator engaging with this workflow and how you will be supported. And you will then be able to see how underneath the components are well managed, properly architected and governed and secure, so that you can understand how this could be built out, modified, or expanded into many different areas. And with that, I'll hand this over to David.
Thank you, John. So let me share my screen and show you the demonstration of what we just talked about. So, and see this this agent in action right now in the multiple ways it can be leveraged in Dataiku. So first, as we said earlier, this agent in a flow in Dataiku can be leveraged as a batch process, meaning that we imagine a scenario where we get some qualified alerts that come into our system, and each day or at a frequency of our choice, we will trigger the alerts reporting system that will take these individual alerts as input and start investigating on their own and produce a report that will be available for the investigator as a starting point for the investigation. So using all the tools available and described previously, the agent has looked through some potential leads, through some data, and generated a first investigation report, from which we have a summary here in an email that is automatically sent to the investigator at the end of the generation of this report. So here we have, just for these 4 alerts, a very short and understandable summary in 2 sentences of what has happened for the specific alert. And if we want to go into more details, we can log to our Dataiku dashboard and go through the report in itself in more depth. So here in this first page, I am seeing the first alert with, on the left, the initial report that has been generated by our agent. And we'll go into some more details about how it's built. And on the right, I have my other capability, my other way of calling my agent that we'll see also later, which is an interactive chatbot that will still leverage the same architecture that we described earlier, but in a real-time interactive way. So to start with, the report on the left has some structure that has been user-defined. So we have some overall information about the alert itself. As you can see, the rule that was triggered to generate it, the transaction ID, some account numbers for the origination, the target account, and the short summary. But when we go below, the agent actually has used his reasoning ability and the tools accessible to it to generate a report that is really targeted to the leads that it has found during its initial investigation. So we can see here that we have a table of content that is not generic, but is really depending on the information that were found by the agent on this specific alert. Now, if we go on the second one, and this one will go into more details about the content about this report, we can see that previously we had 3 subparts in addition to the initial summary. And in this one, we only have 2 that were identified as interesting leads to be investigated by the agent. Now, if we go a bit below, we can see what has been found and raised by the agent while doing the investigation. So as we saw in the architecture slide, the agent was able to find some overall information about the customers at the origin and at the target of the transaction that was suggested as an alert. And these information are summarized here with some additional reasoning based on whether or not this information should be flagged in some particular way. So as we can see here, the first layer of investigation has found that there was some abnormal number of transactions, so very low number of transactions for this company in particular that might be suspicious. We also get some recommended further investigation, and we can see that in a way it is possible to iterate using the agent and build some complex architecture that still uses this modular component, but let them dialogue between them to build some more complex investigation. If we go a bit below, we have some information about the 2 counterparts of this transaction, the account numbers that they have, the balances, the currencies. Here we have also a key shareholder that has been identified that might be of interest. Some other risk factors can be found. And since we are leveraging a graph exploration tool, we also have in the report the graph itself that has been shown to the and really added to the report. So what happens is that when the agent is investigating by using the graph tool, it generates some cipher queries, some queries that are specific to the graph database that contains the information about transactions and holdings, etc. And it surfaces this information back to the orchestrating agent that can then input this information in the final report, so that as an investigator, I can really start from what I see here and get some direct visual insight and trust what the agent has been generating. So for example, here I have this Stephen Monroe individual that has been found as a key shareholder of my target account company. And what I can do if I want to investigate a bit deeper is on the right-hand side, run some additional investigation on that particular individual. So this is what I had done here. I want to just add some additional information to what my report has given me in a more static way. So I asked some information about the risk of the individual Stephen Monroe, and I see that my agent is looking through all the data and the tools that it has at its disposal to provide me with a summary of information about him. So I have information about its personal profile, its business connections, eventually if it's a politically exposed person, or if some news were found that are particularly interesting for that individual, financial activity, etc. And based on that, and based on the prompts that we provided to the agent, it can summarize these findings and produce a risk assessment. And so as an investigator, I get to understand the data that was used to generate this assessment, plus the conclusion made from the agent. I can also have access to the Cypher queries, like previously, if I want to dig a bit deeper, and even to the news that were found during the web search. Now, if I even want to go even deeper and to explore the graph further than what has been done so far, I can also take this query back into our graph exploration tool in Dataiku and see for myself if I can find some other patterns starting from this query that has been generated. So for example, looking at my original company, I can, with a click, expand to see its neighbor, which are the bank accounts. This was the bank account which had a suspicious activity. You can see it here. The transaction was to this bank account, but I can look at the other bank account that received a transaction from this company. And going through there, I can see the complexity of that I can get in terms of transaction. And this is where the agent can be really interesting to analyze these like webs of transactions and eventually get some analysis on the distribution of the amounts, of the frequency, etc. And it's also one of the values of having agents running these kinds of analysis, because as you can see, it's a very iterative process where it's hard to know in advance in which direction you want to go. And you need to go in the direction in an iterative way. And from each step, take decision, use some reasoning to see in which other direction you want to go. So, for example, thinking about these transactions that were made, let's see. And when you get, like I said, to another node that might be interesting, you can always come back to your conversational interface, and like I did before when analyzing an individual, analyze a company like I did here, and get some information similarly to what I had before. And particularly looking at the transaction and the bank account structure, I can see here, for example, for this company, which has 5 bank accounts, it could be hard to identify potential transaction patterns, and I can see how like tools given to such an agent can be very helpful to have a first view of potential red flags in terms of the distribution of the transaction that can be hard to pinpoint and to see from a graph perspective. And still, as previously, from the data that has been retrieved through the agent, I get an assessment and I get my sources that I can then go through and use to do my manual investigation on my side. Now, going to my third alert, I can see again that my structure is also different here. So in particular, the agent has identified some risks related to cross-border, cross-currency transaction patterns. And we can see that really depending on the type of alert and the type of insight that it generated, it can go into very different directions. So for example, here, it really focuses on the cross-currency transaction and the fact that there were some high-risk classification on some accounts that were found in their connections. Still, as previously, we have access to the Cypher queries and are able to really source the information that was generated in this report. And if at some point in our analysis we feel that we have reached a state where we want to like prepare for a SAR, so a suspicious activity report, we also have the ability to generate a preparation report that will take this information plus all the necessary information that is needed to fill in such a report and send it by email to the relevant stakeholder, who will be able afterwards to review this information and eventually file it for real. So you can really see how both these components, they leverage an agent that is really that has the purpose of accelerating and being an assistant to give more power and more tools available to the investigator. So, for example, here for the SAR that was prepared, it from this command generates a SAR preparation document that I can see afterwards in here that contains information about the alert itself, some IDs and some amounts that can then be used for the actual SAR filing. So now what I'm going to do is to show you a bit under the cover what is going on to generate such a report and build the overall agent architecture. So this is part of the flow that we have below. The flow that contains both the data, the logic, and the agent architecture to support this decision-making process. In this box here, I have a view of the 5 agents that I have in my project. So this one, which is the overarching orchestrating agent, and 4 individual ones, which are all specific to one subtask of this report generation and AML investigation assistant. If I go inside this agent, I can see here the screen, which is a really simple way of creating my own agent. So these are called visual agents, meaning that you don't need to write any line of code to create them and to really leverage some complex tools and put them into a process. In this screen, I have chosen my LLM. I have given it a prompt, and then I can select some tools that will be accessible and understandable through some description to my AML investigation assistant agent, and to be used when deemed necessary by my orchestrating agent. So these are all visual tools. I can add a tool just like that and add one from my library of tools that has been created in this project as well. So you can see how simple it is to add some new tool if necessary. And this is also the power of the agent architecture in Dataiku, is that it's very modular in a way that here, for example, these 4 agents, these 4 tools are actual agents that I have connected back to my orchestrating agent. So I can update these individual agents without changing my orchestrating agent. And I can improve them individually, and I can also use them in other projects if I need to. If I go in my tools screen, I can have a look, improve, configure all my individual tools. If I have a look, for example, at my, maybe not this one, at my KYC search tool, this is a really simple dataset lookup tool. So I have my golden data source that has been shared in this project, and I can look through it with an ID and get the information. I also have some knowledge bank search. So I have unstructured document data in PDF, for example. I can, with visual tools, put this information into a knowledge bank inside Dataiku, and then access this knowledge bank through a tool that I connect to an agent. And I can also configure some emailing tool that really make all this process completely automated. So if I want my agent to send some email or some Slack, some Teams, it's also possible easily. Now going back to the flow, I can see that this agent is being used to in some recipes, so some data transformation inside the flow to transform some data and to augment it. So the data that I have as an input is very basic. So it's really the inputs, the alerts that were generated by my system. And from there, I have the ability to call my agent in a static way and have it being called through a specific additional prompt, so specific to the data that I'm sending to him and to the task that I want him to perform. And based on that information, that prompt, the alert ID, it will use the tools as necessary to generate my initial analysis. I'm doing a few steps of engineering then to search into some more direction and generate the initial reports. And the following steps are there to reformat a bit the report, add some titles, etc. Always using a combination of visual tools, of LLMs in a standard way, and sometimes some code also to integrate some of the images. And what is also interesting is that not only can I leverage my my agent inside the flow like I did here, so I can leverage it inside the flow and automate the call of this agent like I did through a scenario. So this is the email that I showed you at the beginning. Basically, as my input data set changes, or for example, at a set frequency, I can have this scenario run. So what it will do is that it will call the agent in the flow, like what we have seen before, build the reports, and when it's done, it will send an email with the summary that we had seen before. But not only can I use it inside the flow like this, but also through the interface that we have seen here on the right in an object called Agent Connect that can be used to have conversation with this agent. And one of the important part of Agent Connect and all the calls to any agent is that we want to keep track of how the agent was called and what kind of of responses did it provide, and evaluate these responses and iteratively improve the quality of these responses through additional work. And this is what we can do with our other tool called Traces Explorer, which, as you can see here, we can look through all the questions that we ask to our agent and see exactly what happened. And as you can see here, it can be pretty complex. And in particular, when you have agent architecture leveraging multiple layers of agents and tools, you still want to understand what is the sequentiality of what was called and why. And this is what we can provide here. So not only we can see in which order and with which prompt each of these agents were called. So for example, here we had a thinking phase before going into the graph exploration tool, which is one of the sub-agents of the orchestrating agent. Then thinking again about what to do next. So for example, here saying that it will check the PEP, the politically exposed person status. So then calling the PEP agent, etc. We can really have a sequential view of what is going on. So this is a really important tool, this Visual Traces Explorer, to understand what is going on, to have an overall view of where what is the agent doing, and not like let it be a black box. Really understand what is going on. Have also the cost of my prompt to understand, to see like if you put it at scale, what would be the expected cost. Eventually, if there are some trade-offs between switching from a more expensive LLM to a cheaper one. And once you have also a lot of processes going on, trying to optimize the time spent. And this can be done by seeing here which are the steps, the calls, the tools that might take a lot of time to be performed. And basically, all of this is to have really a governed way to use LLM and agents in the platform, in Dataiku, because as these agents are going to perform more and more tasks going further, you really want to make sure that they perform them in the way that you have designed them to do so, and in an efficient and cost-effective way. And with this, I think I'm going to unshare my screen, and we can move on to the Q&A session.
Excellent. Thank you, Dave. I'll bring up a little slide here just with some contact information and so on. We'll begin to kind of round out the conversation. So I really appreciate folks asking so many excellent questions on the left, many of which I think we've gotten to. There's one to say that I was in the midst of answering as David was closing out, and we can reach out from there. I would say that if you have questions, now would be the time to kind of get them into the chat on the left-hand side. We'll try to tackle a couple there. But as you will see from the screen I'm about to share with you all, you can also, of course, always reach out to us, and we would very much encourage you to do so. So you can reach out to us at, let's get this all nicely done. There you are. So you can reach out to myself directly. You can obviously always reach out on our website, dataiku.com, and you can engage with us as you see fit. I think there might be a little bit of background noise as well. Not sure from my side or yours, Jacob. What is from your side, David? He's moving into another room to free us from the difficult background noise. So we have a couple of questions on the left-hand side. I'll try to get to a couple of them quickly. So in terms of the source systems and transactions and so on, those can be many and varied. So this particular example used a variety of realistic synthetic data sources, as well as some publicly available sources. In your own firm, you would imagine swapping those out for capabilities that are particular to you. So you may have, for example, of course, your own internal information that would be incredibly valuable and also securely contained, which Dataiku will be able to access without any additional risk because we run internal within your own walls. Then on top of that, you might have access to various just generic public web searches, dedicated databases that you might pay access to or that you access generally. And of course, you might be bringing on new pieces of information as you move forward. In terms of whether or not the process is entirely LLM based, so this is a great question. As you saw, LLMs are critical components of each of the agentic behaviors being performed. You absolutely can directly integrate RAG or vector database capabilities. Those RAG capabilities are also very easy to spin up in Dataiku. As you saw from David, you can build out many things in Dataiku entirely using visual capabilities and then place additional capabilities on top. That would include the setting up of, for example, a retrieval augmented generation workflow in which database various unstructured information is processed into a knowledge bank, which then the agent or an LLM more generally can access and work with. We don't particularly show that in this example, but you can absolutely imagine that being another component of this capability. In terms of some other questions that we're seeing here, and again, trying to get to them quickly. As I said, yeah, various and sundry different sources. And of course, anyone who is interested in following up from here, you can reach out to me or to the contact information associated with the invite. And indeed, Dataiku offers both self-service trainings and workshops where you can see all of this in action. And of course, if your firm is interested in leveraging Dataiku in this way, or for any of the other use cases you saw, or other use cases you might now be imagining you might want to pursue, you can of course reach out to us, and Dataiku could set up demonstrations, workshops, and other abilities for you to engage. Excellent. Seeing some questions again about protocols and so on. As mentioned before, Dataiku is able to leverage any protocols that your teams have decided on, MCP or A2A, but also does not require that those protocols be used. Instead, you can use Dataiku's existing flow. Dataiku is agnostic in that sense and highly collaborative with different approaches. Excellent.
I see
David,
there is
are there
a
any
question.
questions that you're seeing? Yeah, please go right ahead.
Yes, there was a question about what is the source system for email transaction. So this I think you answered. But on the GraphDB tool that is used, so the tool that we use is something that we built internally that is soon to be released. That is leveraging Kuzu as a graph database, and that will integrate also with Neo4j and probably with other graph database as well, since we have a policy or kind of a way of integrating with as many tools as possible when we feel that they are interesting for our customers.
Absolutely.
And I saw also another question about the agentic framework that we are using underneath. So in this particular example, we are using Agent Executor, but we also have other examples leveraging LangGraph as our agentic framework.
Excellent. I also saw a couple of questions about, well, so one is a nice quick question here about platform support and so on. Yes. So Dataiku is completely agnostic as to which models you use. So we have built-in connectors for essentially all of the major models out there and their multiple versions. You can also easily build custom connectors to any arbitrary LLM. And again, those LLMs could be literally public-facing LLMs, although in the vast majority of cases for a financial services firm, that wouldn't be appropriate. Instead, you can just as easily connect to a privately hosted LLM in your own cloud, or a completely on-premise LLM. So some of our clients working with particularly secure data have their own internal LLMs completely inside of their own walls physically and connect directly to those as well. There was also a couple of questions about things like compliance, data movement, and so on. So Dataiku allows you to access data only as approved by your own internal IT teams. And as mentioned, Dataiku can run inside of your own walls. So there are no incremental security or compliance risks introduced by Dataiku because it obeys and respects all of the existing constraints and rules that you have in place. So if data is not supposed to be moved across from different locations, Dataiku will respect that. But similarly, if you are allowed to access data, but it's just in very disparate systems, Dataiku makes that very easy. So essentially, you can imagine that whatever existing constraints you have that are appropriate and are based on the kind of fundamental compliance of your firm, those will not be altered. But similarly, if the constraints are more along the lines of ease of access, straightforwardness of access, systems being disconnected inherently, that is something that Dataiku can immediately help you solve. And we often see teams gain a great deal of benefit from that. It also means, of course, that the IT and technology folks are very comfortable as well because the fundamental requirements remain in place. Excellent. So some questions here. Yeah, go ahead, David, please.
I see a question from Kia. Is it possible to create a planner agent using a larger LLM and executor agents? So yes, it's possible in multiple different ways. So what I showed you during the demo is a visual agent where you configure a single LLM. So you could think about this as the planner agent. So you could give it a large LLM, and for each of the tools that might be executor agent, you give smaller LLMs. So this is one possible architecture. It's also possible if you have more complex ways of integrating your executors with your planner to build a completely custom code agent. So this is not something that I showed directly, but two of our agents in our architecture are code agents because they leverage more complex tools that has not been packaged as visual tools. And you have complete flexibility in the LLM that you are using and in the kind of tools that you want to develop, as long as there are Python that can be wrapped into a Python function.
Absolutely. Also seeing some questions about things like hardware or access to it, and indeed using it for other use cases. So these are important questions. So Dataiku is something that your team would bring into your organization. So it can be run entirely in the cloud on our own systems, but in the vast majority of financial services cases, that is not the arrangement that's used. Instead, Dataiku will be installed into your own private cloud, or indeed on your own hardware on premise. All of those arrangements are possible. And this is why we have so many clients working with us who are in extremely large, complex, highly secured institutions, not just in banking, and by the way. So around this, though, the important point is Dataiku is not simply used for this capability. Dataiku can be used for a vast array of use cases. We mentioned a few of them earlier, but keep in mind that Dataiku is used well beyond simply AML and across the entire banking universe. We have clients using us for marketing and analytics, clients using us for financial planning, other clients using us for front office support and sales, as well as many operational tasks in the background. This is why if when you saw what David was showing you, he showed you the front end, all of which is completely customizable by your teams. And when you went inside of the kind of meat and the components that made up the solution, all of those are available for your teams to customize. They might be customized directly by yourselves using the no-code capabilities or by the full code capabilities, or you might ask teams who support you to build components out or modify them to meet your needs. So take everything that you saw here as essentially kind of a Lego set that we've assembled in a particular way to showcase to you what could be done. You can add more components to it or take components away or rebuild those components into something entirely new for you. Excellent. In terms of licensing and so on, the most important thing there would be for you to contact us at dataiku.com, or you can reach out to myself and I will put you directly in touch with our sales team, who will be able to talk to you all about what it would look like to trial Dataiku and then bring it inside of your organization. At the most basic level, I'll tell you that the way Dataiku ultimately works is that we charge by seats, like licenses, users. Therefore, you can build as much as you like, as complex as you like, a process inside of Dataiku, and all that you end up paying for is that you and your team are accessing it. You don't pay for the amount of access or anything like that. So it's a very efficient model whereby you can use it to achieve everything that you might want without any kind of additional incremental cost. The cost is simply that you use and have access to the system. Marvelous. I know there's a few other. Oh, go ahead, David, please.
Yeah, there is one about our platform support choice of LLM models. I don't think it was answered before. So in our example, we are using a mix of Amazon and OpenAI models, but it's well, we support using our what we call our LLM mesh. So it's our way of connecting to most of the LLM provider. So we support most of them, including ones that you can self-host, ones that you can get through APIs in a very secure way, and included in our way of connecting to those LLM is a way of monitoring and controlling access to these LLM for your teams. So you can give access to specific models to certain groups in your company. Plus, we have a way of monitoring the cost, the calls, limiting all of this so that you really have control on the way these models are used, but still getting the flexibility of being able to connect to all of them.
Marvelous. Excellent. So I'll begin to close out the conversation here. I know there's still a few kind of open questions and so on. For all of those, I would encourage you to travel to our website, to follow the links associated with this webinar. You can also, as I said, reach out to myself directly, and I'd be happy to put you in touch with whoever you'd like within our organization that can help move this forward. I think I'll emphasize, and I can see the question here at the end about feedback and so on. I'll emphasize that what you saw here is very much the experience of a particular project in action. Remember that Dataiku 1 allows you to build many different projects, but also allows all of those projects to be governed. So if you imagine the use of Dataiku, it's going to be yourselves using it. It would be teams that support you. It would be teams that support simply the underlying infrastructure of your entire technology stack, like your core IT and technology people. And it would also be compliance, audit, and other teams helping to ensure that everything that's being done is being done appropriately. All of these teams are able to work together in Dataiku in the various appropriate ways for their roles, so that something built in Dataiku is not simply efficient and agile and effective, but it's also highly secure, very effectively governed, and fully auditable. So I'll leave you with that important point, that Dataiku is not only solving your problems, but ensuring that they are solved appropriately and effectively. So on that note, thank you so much for taking the time with us today. Any follow-up questions, including any questions that didn't get answered, feel free, as I said, to reach out directly to myself or to the broader Dataiku team. We'll be happy to engage with you. So thank you so much. Have a wonderful rest of your day.
Thank you.